Welcome to the Calculus A section. In this section, we will be looking at an important concept for the study of calculus: tangent lines. Now, there's a step-by-step process to finding the tangent line. Therefore, the easiest way to grasp the concept is to try a problem. So, let's say we have to find the line tangent to the function f of x is equal to x squared minus 6x plus 9. Okay. And so, say we wanted to find the point of tangency at x equals 2. So in order to do this, we can do this in 4 easy steps. So our first step involves finding the slope of the secant line, or the original slope of the function, and that's given by m is equal to f of 3 minus f of 2 over 3 of 2. This is 3 minus 2, sorry. This is the same thing as having a function x and wanting to find the slope of the line at x equals 2 per se, and this would be 3 and this would be 2, and we take the difference between the two x coordinates and we take the difference between the two y coordinates to find the slope of the line. So similarly, we're going to do this to find the slope of the secant line. And we know that f of 3 is going to equal 0 because 3 squared minus 6 times 3 plus 9 is going to be 9 plus 9, which is 18, minus 18 is going to be 0. And we know that f of 2 is going to be 1. So 1 over 3 minus 2 is going to give us negative 1 in this situation. And now that gives us step 2. So next we're going to approximate the equation of the slope of the tangent line. So that is given by m is equal to f of x minus f of 2 over 3 minus 2. Now, in order to understand this, we have to go a little bit deeper into calculus, but I'll give you a little hint. So x is actually equal to a minus h, right? And in order to find the derivative, or the tangent line of a function, we are going to have to compute f of my prime of x is equal to f of a plus h minus f of a over h, my apologies. And that would give us our derivative. So what we're doing is we're doing a makeshift way to find our derivative. So knowing that, we are going to expand this, and we get m is equal to x squared minus 6x plus 9 minus 4 minus 12 plus 9 all over, sorry, this is not 3 minus 2, x minus 2, all over x minus 2, my apologies. And that gives us x squared minus 6x plus 8 all over x minus 2, and that is going to be our slope of our tangent line. So now, in order to compute this, if we were to plug in our value 2, that's our point of tangency, our desired point of tangency. If we plug that in, we're going to get 4 minus 12 plus 8 all over 0. And the reason why this doesn't work is because we can't divide by 0. So step 3, we are going to use a chart to help us approximate the value of the point of tangency at x equals 2. So first we're going to start with our original point, 3. And we know that our secant line at 3 is equal to negative 1. There's no change in x from our original point, and we can find our slope of tangency by plugging in our change of x into our equation of our tangent line, which is negative 6 plus 8, x minus 2. So if we plug in our change of x, we're going to get 0 minus 0 plus 8 over 0 minus 2, and easy enough, that is negative 4. That is our slope of the tangent at the point x equals 3. But we don't want the slope of the tangent at x equals 3. We want the slope of the tangent at x equals 2. So we're going to slowly change and see how our slope of the tangent changes with it. So at 2.5, in order to find our secant line, we're going to plug that back into our original equation. If you could recall shortly, that was x squared minus 6x plus 9 over x minus 2. That's a huge difference, I know. So that's going to be 2.5 squared minus 6 times 2.5 plus 9, oh no, plus 9 all over 2.5 minus 2. And so that is going to give us the value of negative 1.5. Sorry, that was some quick mental math. And now our change in x is going to be 0.5 from our original 3. And we can plug this back into our equation, and we will get negative 3.5. I'm going to leave the work to you guys because that's where you really build character. So we can still go down back to, we're still approaching 2, so we're going to go to 2.1 this time. And so our secant line is going to be negative 1.9, our change in x is going to be 0.9, and our slope of the tangent is going to be negative 3.1. As you can see, we're starting to go to this trend. So we start at negative 4, we change to approximately 2.5, and we go to negative 3.5, we change to 2.1, we're going to negative 3.1, and if you could make any guess where our slope of the tangent line is, it's looking like negative 3, but I don't want to spoil it. So we can go to 2.01, my apologies, and our secant line is going to be 1.99. Whoa, that's really close to that. And then our change in x is going to be 0.99, and our slope of the tangent is going to be negative 3.01. So just to be sure, just to make sure that our slope of the tangent is going to be negative 3 and our secant is going to be negative 2, we're going to go 2.001, and we're just going the extra mile here. And we know that our slope or our secant line is going to be negative 1.99. Our change in x is 0.999, and our slope of the tangent is going to be negative 3.001, and that looks darn close to negative 3 and negative 2 to me. So we're going to go back to our step 3, and we get that our slope of the secant line is going to be negative 2 at x equals 2, and we get that our slope of the tangent line is going to be negative 3. So unless your teacher asks what's the slope of the secant line, we don't really need this value, so it's just very good practice. So we're going to cross that out. It's a little sad. So we know that our equation of the tangent line is given by y minus y1 is equal to m, which is our slope, x minus x1. And these subscripts of 1 are indicative of the points that we are dealing with, the points of our tangency. And we know our point of tangency at x is 2, so we want to find our point of tangency at y. And we already did this when we were dealing with f of 2. That is the original function's point at x equals 2, and we were given the value 1. So y minus 1 is equal to our slope of tangent, negative 3 times x minus 2. And we're going to leave it in that form so we don't make any more mistakes. But that is our equation of the tangent line to the function x squared minus 6x plus 9 at x equals 2. Now there's a lot of problems on the website. If you need more help, there are plenty of resources for you. I hope you enjoyed the video. Thank you.